This lesson is on multiplying radical expressions in real-life situations involving radicals. We need to recall our rules of exponents and our rules of radicals. So the first thing that we're going to use out of the exponent, the only one that we're going to use, is the product rule. Product is multiplication. So if I have the same base and I'm multiplying those two numbers together, which is the same number, I am going to add the exponents. For example, 3 to the 4th times 3 to the 2nd is 3 to the 6th. Okay, because 4 plus 2 is 6. Now, on the properties of radicals, we're going to use the first one, but I prefer that you read this backwards. If I have the square root of 2 times the square root of 3, that is the square root of 2 times 3, or the square root of 6. So whatever is underneath when I'm multiplying, as long as it has the same index, that's the number on top, but when it's squared, we don't write the 2. I multiply what is inside the radical, and it stays inside the radical. Unless it's a repeat, then I take it out later. Okay, the one that we have already used in the previous video says that if I have like the square root of 5 squared, that's just 5. The square root undoes the squaring. And the same thing, if I have the square root of 5 and I'm squaring that whole thing, it's still 5 because the squaring undoes the square root. Okay? They're kind of opposites. Do some examples of products of radical expressions. And I have the two properties, the exponent property for products and the radical property for products over here to remind me of what I'm doing when I come to that. Okay, so my first problem, I'm going to find the simplified product of 5 times the square root of 3x cubed times 2 times the square root of 6x to the 5th. So the first thing that I'm going to do is I'm going to take the outside times the outside, so 5 times 2, and then the inside times the inside. So I'm using this one backwards. So I have the 3 times the 6, and then x cubed times x to the 5th. And that's what I did. I took 5 times 2 on the outside, and then I combined the inside as 3 times 6 times x cubed times x to the 5th. Now what I'm going to do is I'm actually going to multiply out the 5 times 2, but I'm going to separate the 6 into 3 times 2, into my primes. I'm going to add the exponents for my x cubed and my x to the 5th because they're being multiplied, so I'm using the first property over here. And I come up with 10, 3 times 3 times 2 times x to the 8th. Now I can start taking out what is inside the radical of the pairs. So there's a pair of 3's here, so I'm going to take that 3 out, and the x to the 8th, there's 4 pairs of x squared there. So I'm going to take x to the 4 out. So I end up with 3 times 10 is 30. The x to the 4th came out, and I'm left with only the 2 inside. So my final answer is 30x to the 4th square root 2. Okay, another one, find the simplified product. I'm going to take the outside first, 3 times 1. When it's not listed, it's a 1, because 1 times anything is itself. So that is a 1 right there. It doesn't change anything. 3 times 1, which is 3 on the outside, and then in the inside, I'm going to have 8 times 12 and x times x cubed. So I did break it down already. So 3 times 1 is 3. The 8 is 2 times 2, which is 4, times 2 is 8. Okay, so that's my primes for the 8. You can do the factor tree with the number on here. Okay, then 12 is 3 times 4, and 4 breaks down to 2 times 2. So right now, the first 3 2's is the 8, and the 3 and the 2 2's is the 12. And then I have times x from here times x cubed. Okay, any pairs, I'm going to take it out. So this is going to be a 2 that comes out, and another 2 for the last ones that come out. I'm left with 2 times 3 inside. So my next step was to take out the 2 from here and the 2 from here. So now I have 3 times 2 times 2 on the outside, and I have 3 times 2, what's left in the middle here, but I switched the order. 3 times 2 in the inside, and I added my exponents, so I have x to the 4th. Now I'm going to take out that x to the 4th, and I'm going to do this multiplication here. 3 times 2 is 6, times 2 is 12, so I should have 12 out front. There are 2 sets of x squared for x to the 4th, so I'm going to take out x squared. So I'm going to have 12x squared on the outside, and I'm going to multiply this 3 times 2 back again, so I have 6 in the inside. So my final answer is 12x squared, square root 6. Okay. Okay, real life examples. Okay, note underneath me is there is only one calculation. A rounded answer is appropriate, okay? Because I'm only doing one calculation. I'm not using that calculation to do another calculation, to do another calculation, to do another calculation. I'm only doing one calculation. So I want a rounded answer, because if I come up to anybody who's walking down the street and I say 9.8 times the square root of 1500, they're not going to know what I'm talking about, or it takes some figuring to figure out what around that number of what I'm talking about. There is a scientific calculator attached to the lesson, and I will be using a scientific calculator to do my computation here. So Hiroki is calculating the speed of a tsunami in meters per second squared. The formula is that speed is equal to the square root of 9 8/10 times d. D is ocean depth in meters. So in this case, the ocean has 1,500 meters deep. Okay. How fast was the wave in meters per second squared? So basically, they're giving me D, and they're giving me the formula, so I'm plugging in that 1,500 into the D. So if I plug that in, I have speed is equal to the square root, or 9 8/10 times 1,500, and then it's in meters per second squared. So I'm going to pull out my calculator, show you how to use this. Okay, on a scientific calculator, all calculators are different, but for the most part, you put in the inside first, and then you press the square root. So I have 9.8, which is 9 8/10, times 1,500, and that is equal to 14,700, and then I want the square root of that number. So if I take the square root of it, it's only going to give me the positive value on the calculator. So I have the square root of 14,700 is equal to 121 and about 24 hundredths. So my answer, and now this would be plus or minus, but they already gave me the formula, so because there's no negative out front, I'm assuming that it's positive. And so that is my answer. It's going to be positive 121 and 24 hundredths meters per second squared. Next problem is Lori recently purchased a painting with an area of 780 centimeters squared. How much wood does Lori need to make the frame? Okay, so I've got a square painting here, and I know that the area of that square is 780 centimeters squared. Now, if it's a square, each side of the all equal, okay? And my square, the side, we're going to call that x centimeters. So x centimeters times x centimeters, if you want to do length times width, would be x squared equals the 780. So I have x squared equals 780 centimeters squared. Or if you know that the area of a square is the side squared, it's the same thing. Okay, I take the square root of 780 centimeters squared. Now, you should be able to do that on the calculator. You're taking 780 and square rooting it. I came up with, and now this is plus or minus because I'm taking the square root. So I get a positive or a negative about 27.93 or 27 and 93 hundredths centimeters. Okay, now when I'm thinking about the frame, I think if it lines up right here, it's going to stretch to the end, one piece. And then this next piece is going to go from here to this end. So it's a little bit longer than the x. It's not just x plus x plus x plus x. It's x plus the width of the piece of wood. So I have x plus the width of the piece of wood 4 times. I've got 1, 2, and then this one, 3, and then 4. So the amount of wood that I'm purchasing is 4 times x, the positive value, because length is measured in positive, so I eliminate the negative, plus 4 times the width of the wood in centimeters. Now, they didn't give me that, so I'm just going to have the person who's going to buy the wood figure out what the width of the wood is in centimeters when they're there buying it, and then multiply it by 4 and add it to my answer. So the amount of wood is 4, because there's 4 x's going around, times 27 and 93 hundredths centimeters plus 4 times the width of the wood in centimeters. So as far as I can get is the amount of wood is 111 and 72 hundredths centimeters plus 4 times the width of the wood in centimeters.